Hey, welcome back. Today on my bench I have something a little different, something that's a little more closer to my heart. This is a Roberts R600 AM FM. It's got dust on it. It's a 2-band AM, 1-band FM. This is a table radio, made in England. It has quite a turntable built on it, so that when you're eating your toast in the morning, toast and jam, you can either direct it at you or direct it away. This is a nice little unit. I bought this on eBay last year with the intention of doing a little restoration on it, a revival if it needs it. I don't even know if it works. Making a video. I find antique or vintage European electronics very fascinating to me. It's one of my favorite things I go after when I see vintage stuff. And I like collecting radios, I'll admit it. And this kind of talks to me here. It's kind of a nice unit. I know these are probably common as dirt in the UK and other parts of Europe, but here in Canada you just don't see this stuff. And when I did see it on eBay, I snapped it up. The price was good. Okay, so let's have a look at it. It's a table radio, like I said, with the turntable. You saw it in action. It's got a carrying handle. It's a battery powered unit. There's no AC input on this. For controls, we have our off volume. It clicks off. We have a headphone jack, a tone switch, and then we have our 3 bands: medium wave, long wave, VHF. That one doesn't stick. Automatic frequency control for the FM band, and then tuning. A long aerial antenna, which looks like it's in really good shape, which is good. And then there's also an input for an auxiliary antenna. If you wanted to get better reception on the long wave bands. Speaker up front, looks like it's a 3x6 maybe, oval. The back is not removable. So how do we get into this thing? Well, you see there's this little secret here. There's a hole here. You just pull this back and lift it up. And there's a spring here that you push up against, and this lump of wood looks like it's a solid walnut, I think. I don't know. I'm not sure. So there's a little serial number action going on there. Very important message for us too. And then we have our interior. So somebody has chopped off the battery connector, and I believe the battery it uses is a big square chunky thing that fits in this area here. We don't have these in North America. I think it's a 9-volt battery, to tell you the truth, and it fits in this area here. But it looks like somebody hacked off the battery connector, which is no problem. We can deal with that. We can figure out a thing with C cells or something. And I believe it's 9 volts. So let's have a look at putting some power to this thing. Maybe we can get it to make a noise. So let's connect up our power supply. I got 9 volts sitting here on my bench supply, and it's ready to go. Turn up the current a little, make sure I got enough current. That's off. Okay. I believe this is a germanium transistor unit, but I might be wrong. Okay, we're all set for 9 volts. Let's turn it on. Yeah, we got nothing. Absolute silence. We're drawing less than 1 meter, barely reads it. Let's see. Let me set up my ammeter here. Hang on. Okay, I got an ammeter in series with the power supply. Let's turn it on and see what we got. About 11 milliamps and steady. That is not happening. There's no sound. Nothing. I scan through the band, the current doesn't change. Okay, so we got a problem with power getting through this thing. So let's disconnect this. Now, what are we going to do next? Well, let's get the chassis out of the box here. And from what I can see, if you can see it too, it looks like there's two screws, one here and one here. And if I remove these screws, let's try it. I have a feeling the chassis comes out the top. But then I need to remove this as well, I think, for the antenna. Let's try this. And then I can put the box aside. Put the box aside for cleaning. Although it doesn't really need much cleaning. Something fell out. I don't know if that's supposed to be loose or not. Okay. Let's desolder these speaker wires. They're just laid on intact. So I'm assuming that is the logical step for separating the two. And while I'm here, I am going to very quickly zap this voice coil to see what kind of, if it's working or not. I'm not gonna burn it out. I'm just gonna give it a short. Yeah, it's working. So let's push this out top, I think. Maybe I'm wrong. No, it's just stuck in there a bit. It's just stuck in with dust. There we go. Yeah, there's sticky stuff inside. Maybe somebody spilled something. It's all sticky in here. I clean all that out. So why isn't our radio working? Could be the phone jack. Let me get rid of that. Let me get rid of this. You might have a defective phone jack here. You might not be letting, because this is our speaker terminals, the two white wires. And for whatever reason, there's two wires going to the phone jack and one wire leaving it. Oh no, okay. So let's attach a bench speaker. And right here. Okay, let's get our power supply again. We're definitely getting sound through now. Or we're not getting any audio. Oh, hang on. We're getting something on the FM band. Whoops, it died. Doing some oscillation stuff here. That's full blast, and I'm barely getting any volume. So it looks like we got a little work ahead of us here. So FM band is kind of working. I think his switch is really messed up. We got no AM bands. Oh, hang on. That's full volume. Very quiet. We might have, well, we probably have dead caps in here. That's probably the reason why the low volume. Okay, so that's a good start. We know it's working, and we know what problems we have to deal with right off the bat here. Let's get rid of this power here. We got to clean some switches, and we have to troubleshoot why we got low audio. Very low audio on the... it wasn't drawing heavy current. It was only drawing maybe 20-30 milliamps. Alright, so let's have a good look at this radio. Yeah, like I said, it's got 3 bands. Long wave. Hang on, what are we at here? Medium wave is 550 to 200. 200 to 550. And this here, I don't know where it starts on this band. It goes up to 2 megahertz. That's long wave. That's not right. That's odd how they numbered that. Those aren't meters. Maybe that's meters. No, that can't be right. Not sure. Anyways, let's have a look at this. It's a fairly simple, basic radio. It's germanium transistors. We've got germanium output transistors here. They've got 2 of them wrapped up in a copper heatsink that's transferring some of the heat to the side plate here. And it looks like there's a germanium black glass. That's actually glass tube that the germanium transistor is in, and then they paint it black. And yeah, we got a potentiometer in there for maybe some bias trimming. I'm not sure. And we have a few carbon comp resistors, which are notorious for drifting in value. These are electrolytics. Oh, that one's kind of loose. Kind of loose there, yeah. I think that one's cracked. Flopping around in the wind. Anyways, we've got electrolytics. I'm going to check all these out. I have a feeling the ones in the audio path are open. Okay, got another transistor tucked in behind, underneath the ferrite core. It's an AC 128. Another trim pot. Not sure what that does. Capacitor trimmer. It's got this nice, long, huge antenna bar. And I don't know if you know this, but the size of the bar is proportional to its sensitivity. So if you have a nice big long bar, you're going to get great sensitivity out of this radio. So I expect this is going to be a good performer. Usually when you have a tiny little bar that's only maybe 2.5 inches long, they don't do as well. But yeah, I'm kind of curious as to see how sensitive this thing is. And then we have a couple modules that have the big warning stickers on them. I have a feeling this is the FM module, but I really don't know. And then this one here is probably the front end for the AM. Again, like I said, I don't know for sure. Another trim capacitor. It's mounted on a steel chassis, and it's very nice construction, very well built. Let's have a look at the bottom side. We got our band switches, which I expect need a good cleaning. They're kind of stiff to operate, and we got junk coming in from the top. So I'm going to give these a good cleaning, even if I have to remove them from the board. That'd be a big job, but we'll look at that. PCB board, Rogers radio. It's got a little bit of blob of solder there. Take that off. Yeah, it's pretty basic. Mid-60s era. We've got a BC148. I don't know if that's a silicon or a germanium transistor. It looks like it's a black silicon. And another BC148 back here. AC128. And this one here, this gold glass one is, I can't even read it. Don't want to flex the wires too much. And then a couple of output drivers. And I'm assuming there's some transistors in these modules as well. Now I looked online for a service manual or a schematic. I didn't find anything. I did find one for the R22, and it's a lot similar in design. It doesn't have a tone switch and a few other changes. It's a little more basic model than this one. It's not as elaborate, but I think it will work for the basic stuff like the amplifiers and stuff. But first of all, let's check some of these capacitors. Kind of concerned how that one's flopping around there. Maybe it's okay. Okay, so let's check a few of these capacitors to see what we need to do first. Let's check some of these caps out. Tripod in my way, that's the problem here. .6, that should be all right. Let's check these two small ones. .2 is probably high, depending on what size it is. Let's see here. 7.4 is also a little high. This one here. 1.7, that's good. Okay, this one here. 0.92. That is a 200 microfarad. This one here. 0.5, that's all right. There's a couple big ones here. I think they're power supply filters. This one here. That one's okay. Where does this one terminate? That one goes to here, I think. That one's good as well. So we really don't have any bad capacitors aside from these two tiny ones here, which are reading high. And even them, if I can find a value on one, they're all covered in dust. I can't read it. 2.5 microfarad, is that what it says? 2.5. So even those are okay. That doesn't explain why we have low audio volume on all the bands. So maybe we got a transistor that's out. Might have to do some more troubleshooting on this. So for right now, I think what we should start off with is clean these switches. We got 5 switches here. This one here on the end is your tone control. You can see the capacitors for that circuit, and then the rest of them are, these three middle ones are band switching, and the one on the outside is your AFC for your FM. So let me clean those up. I'll get some spray contact cleaner in them, and then I'll follow it up with some deoxit. I don't think we need to watch that, do we? And I'll get back to you on this. So one thing I want to do is disassemble the radio for cleaning, which involves taking off the front panel, which means pulling off the two knobs and so on, pull up the antenna. But you have to disconnect the headphone jack and the antenna jack from the back side. You have to desolder these wires from the thing so you can actually get it out, and then it's disassembled. You can disassemble it for cleaning. Now, bad thing here about this Roberts radio is these wires are solid core, and if you flex them about 3 or 4 times, they're going to snap on you. So it's very, very important to take digital photos of all the wiring on the circuit boards, where everything goes, because if any of these wires snap on you, and they're all solid core wire, there's no stranded wires here at all, which is pretty poor for electronics wiring. We know that if you use a stranded core wire, it will flex a little bit better. And won't break as easily. But take digital photos of everything, close-ups, and don't be afraid to use up a memory card taking photos of absolutely everything, because if some wire breaks off here and you can't remember where it goes, you'll have something to go back onto. So I got this apart now. I just want to have a little look at it. Got the dial string, goes all the way around, and this card here is quite dirty. This blue card, it looks like it's a plastic of some kind. And then our tuning. And I'm just pulling these knobs off because they're going to get a soak in the ultrasonic cleaner. Pull those off, those are ones that are tight. And then I'll clean all this inside here. It's all got crusty dust and other nastiness. It looks like breadcrumbs and maybe something else. Who knows? So I'll get on with that. Okay, here's where I'm at right now. I went through and I ESR'd these caps. There's what, 1, 2, 3, 4, 5, 6, 7, 8 electrolytics, and they all seem fine. But we have low volume on the speaker. And yesterday I did spray some contact cleaner into the back side of these switches and worked them. They still feel sticky. I'm gonna have to do something more with this, but I haven't put any deoxit in yet. But I just want to see where we're at with how it works, because I'm still kind of perplexed as to why we have a low volume on the speaker. So what I'm going to do is connect power one more time here, and we're going to try to see again what's going on with the. Got my 9-volt supply on, and I got the bench speaker. And here we get a lot of scratchiness from the pot. We are not drawing very much current at all. Probably about 10, 12 milliamps. Let's try different bands. See, these switches are still not. So I guess that's my first priority here, is figure out why we got no audio. We lost our little bit of signal we were getting through before. Alright, added a meter up top here so we can watch current. It's on a 300 milliamp scale. And what are we getting here? We're only getting maybe, well, let's turn this down, maybe we can get a better. Yeah, it's only like 15 milliamps. Where's my speaker connection? And we're not getting any scratchiness. Okay, so let's drive in a signal into the input of the potentiometer here. All right, I got 1000 hertz tone, half a volt, peak to peak, blocking capacitor. And let's turn this on. The current sure jumped there. Let's try this. It doesn't sound like a proper signal. Seems like it's oscillating. That's odd. Okay, so we're getting a signal through the amplifier, but it's just weak. And the only reason for weak through the amplifier is capacitors. And this little section here doesn't really have any capacitors. I'm going to check the value of some of these resistors. I have a feeling some of these have drifted. So let me put this camera on pause. I'm going to get my ohm meter out and I'm going to poke around and check some resistor values here and see what I can find. Maybe I can turn up a reason why this amplifier is it's operating unstable. And I did go through and ohm check these, or diode check these transistors, and they were all okay. But something's just not right here. Okay, let's just keep trying here. I'm not getting anything with an ohm meter on the resistors. There's some that are out of spec by 10%, but 10% out of spec wouldn't cause an amplifier not to work like this. I'm just going to poke around here with my signal. Okay, that's a speaker output right there. Looks like this transistor here is not even doing anything. Okay, the other transistor. Interesting. I'm feeding in half a volt. Okay, there's our signal. This is breaking into oscillation because I don't think the power supply is stable in this thing. Where is... Oh. Let's see here. This is only half a volt going in. Wow. Okay, let's turn this volume down there a little. Let's go to 0.3 volts. Something really unstable with this. I think even though the capacitors test good on ESR, I'm going to have to yank them out because I don't think we have capacitance there that should be. So I think that's going to be my next step. I'm going to yank some of these capacitors and I'm going to really scrutinize them. And I think that's what our problem is right now, is we got bad caps in this thing. Alright, I've done the full recap and I've pretty much tested between each capacitor. I tested each stage of the recap to make sure everything was going right. I did notice that as I went through and started replacing them one by one, the performance of the audio amplifier started to get better. But it's not where I want it to be. It still has a problem. I'll show you what that problem is. Carefully roll this over. I'm going to short any of this. Now, our current meter here, this is set to 300 milliamps per scale. So as I turn this on, you can see it's drawing probably about 10 milliamps or so, 15. Now, I got 1000 hertz signal fed through a capacitor. This one, I don't even know what value it is. It's under 1 microfarad for sure. And that's just to block any DC, because I don't want any DC going back into my signal generator. And a 1000 hertz tone and 0.5 volt peak amplitude. So let's try this out. We get a very weak Now as I increase it, you notice there's a spot here where it's flat, and there's no increase in volume, and there's no increase in current consumption. And then once I hit a point, there's a knee here where I hit it, and it starts to oscillate. And you can hear that. And current goes up. And that's full volume. We don't get any more volume out of the speaker. It's relatively the same volume, but we get more current consumption and we have an oscillation. So we do have a problem with this amplifier. Thankfully, I was able to download the trader service sheet for this from www.radioworkshop.co.uk. Thank you very much for making this possible. So what I'm going to do is I'm going to go through, see there's two potentiometers here, RV3, RV2, RV1 is the volume control, and I want to give this an alignment according to this data service sheet. Let's see here, oh yeah, connect the voltmeter, blah blah blah, milliamp meter. Yeah, we need to set up the quiescent current 3 to 5 milliamps at 20 degrees C. And we're going to go that, and then RV2 is for symmetry at the onset of clipping. So we can go through and do those two checks. We have a spot here where we have to break. It's called link. It doesn't really specify where it is, but it's between the negative 9 volt rail and transistor 6. And another thing to notice is this has a positive ground. So, yeah, I got to be careful that when I'm hooking up my oscilloscopes and stuff. I don't think my 24 volt linear supply is not grounded. I'm pretty sure of it, but I'm going to check it before I continue. So yes, I'll find this link. Need to break it. We need to set this current with RV3, and they are saying 3 to 5 milliamps. Or is that 3.5? I think that's 3 to 5. .7, 3.5. Maybe that is 3.5. So we'll go for 3.5 here. I was thinking maybe set it for 4 if it's between 3 and 5, but I'll just give it a 3.5 milliamps. Okay, something I just noticed and discovered, and I think it's kind of important. This chassis, this metal chassis, is not at ground potential, as I assumed it would be, because I saw ground leads soldered, and there is connections to the metal. Okay, so we're all set up to do current draw test on the output transistors. So let's turn this thing on. And we're getting about 2.6. Settling at 2.6, 2.7. And our adjustment is right here. Let's see if this works, or if we have to clean a pot and get a smaller screwdriver. 3.5. Leave it right there at 3.5. We're still drawing the same current from the power supply. It's probably 16, close to 16 milliamps, 15.5. It's funny we're not getting any audio from the radio at all. These switches. Yeah, but this thing needs a lot of work yet. Still not there. I had a little sleep last night and I was thinking about this, and I have a feeling I got a bad output transistor here, and I'll explain the reason why. Here, let me show you. Let me show you instead of telling you. It's got quite a mess here with hookup wires. Okay, so here's my signal I'm feeding in. It's a 500 millivolts, 1 kilohertz tone. And I got the speaker hooked up. Let's turn this on. But notice how much current it's drawing. Here, let me turn it to 300 milliamp scale. And let me turn this down a bit, because I want to see if we have clipping, premature clipping. So I'm going to feed a signal in. And you notice I keep increasing the volume, but nothing happens. Except the distortion gets worse, clipping gets worse on the bottom. Let's do some probing around these transistors. Okay, so this transistor here, that's which one are we at here? So this is the base, I'm assuming. Yeah, this is the base. This is the collector. This is the emitter. It looks a lot like the base. Okay, let's go to the other transistor, the base. I think this might be the collector. And this is the emitter. I'm not sure if one of those transistors is not working. Let's go with the driver transistor. I think this is the base. Let's see. Yes. What's the clip? I'm not finding the fault here. Okay, so here's where I'm at right now. I have an audio amplifier that doesn't want to work, and it's giving me fits here. You can see the current draw is about 15 milliamps on the amplifier, or the whole radio. If I turn up the volume, get a very weak audio coming through that turns to distortion after I get about 2/3 of the way up on the volume, but it's too quiet to be useful. It's not working. Another thing I also did is I removed all of the transistors, tested them out of circuit. They're all good. Everything's 100% with the transistors as far as I can tell. Now I did find some resistors that were out of tolerance. These are 10% resistors. How many did I change here? And I don't even think I've finished. Looks like I replaced 4 of them so far. So these are all 10% or more out of tolerance, so I changed those ones. I expect there's a couple more that I haven't done yet, but for now we're not worried about the resistors. We're worried about getting a signal through this thing and getting it working. Bad resistors won't cause this problem. It might cause a little bit of distortion, might cause the biasing of the transistors to go out, but it shouldn't cause this problem. So let's do some scoping here. Capacitor here, and signal jumps across, goes transistor, emitter. We are getting a good signal. So here we are on transistor 1 and C18. If I check across C18, which is right here, there's one side and the other. So our signal's getting through that capacitor, everything's fine. And then it goes up to this transistor here, which is transistor 2. This is the base. And this is, what is this? Collector? Yeah, this one's collector. And look how distorted it is. And we're not getting any gain. Here's the where are we? Here's the input. Here's the collector. Here's the emitter. Same garbage. No gain. Distortion. So what's going on with this transistor 2? Now if I check with a voltmeter, it gives us voltages for our transistors. Let me turn this down. Can you get the voltmeter in there? Okay. Here's our base. And we're getting 3.9. Transistor 2. The base says it's 3.1. The collector, we're getting 0.142. Transistor 2, the collector 0.17. That looks correct. And the emitter, 4.5 volts. Transistor 2, 4.5 volts. So why does that signal fall flat in its face on that transistor? I'm looking at, where does transistor 2 get its supply voltage from? It's this is +9 here, goes through R15, can't go through here back down to positive, that's not going to work. Goes through R17 to where? To the common junction of these two transistors. That's where it's getting its voltage. So these two transistors should be about 4.5 volts between the two of them, right? Let's have a look. This transistor and this transistor, 4.5 volts, there it is. And then look at this. If I check this side of the trace, I got 7.3 volts here. 4.6 volts there. Something's wrong with this trace. Why isn't it working? So, what do we got going on here? We got a bad trace on the board, which threw me off for quite a while. And let's check the voltages between these two. And there it is, we got 2.6 volts on a trace that should be 0 ohms. That's my problem. So, let me clean this up. Shut this off. Let me clean this up with some alcohol. I got flux all over from removing transistors. Now we're getting what looks like full volume. So let's try this. But it is a real current hog, this amplifier. So there's idle, 15 milliamps or so. And when I turn it up, right about there it starts to distort, about 150 milliamps, and it does get quite loud. It is fairly loud. It's loud enough for what we're doing. So I'm going to say this amplifier is working. I'm still going to go through and check those resistors, make sure that none of them are out of tolerance, because that can upset things. But it's working now. Alright, now that I got the power amplifier working, or the amplifier, I wanted to adjust the, there's a trim pot here. Which one is it? RV2. This trim pot up here. And what that does is it sets up the balance for the amplifier. The instructions say, connect an oscilloscope to the output across a 5 ohm load, turn the volume control to maximum, apply an audio signal to the top of the volume control and increase the input until clipping is apparent, and then adjust RV2 for symmetry on the onset of clipping. So I went ahead, I was trying to do this alignment, and it wasn't working. Guess why? Okay, here. Started looking at some resistors again, and it appears this thing has a bad case of resistoritis. So I pulled out this one. This one here, you can see that the color bands is blue, gray, orange, silver. So that would be 68K at 10%. So let's test what it says here. And we're getting almost 82K. That one's out. Here's another one. This one here is a 68K as well. Blue, gray, orange, silver, 10%. And let's try this one. Same thing. It's almost up at 82K. So that's the problem with this amplifier is, or this radio in general, is a lot of these resistors have really changed value. Here's a 4.7K at 10%. This one I yanked out the other day, and it's up about 5.2K. This one's an 8.2K at 10%. Let's try it. .2, it's at 9.16. So they're all out of tolerance. This one's a 2.2K. I think this one came back at 2500. Yeah, 2500. So as you can see, this is what I'm fighting here. So I think I'm just going to go through and replace the majority of these. That one's 7.9. And that is supposed to be 6.8K. Yeah, I'm just going to go through and replace the majority of these. I think I did check a couple, and they were okay, so I left them in circuit. But the ones that don't comply to the tolerance are going to be going. So eventually we'll get this thing running good. All right, so we spent a lot of time to get the audio amplifier working again. Well, it was working before, but it's working a lot better now. I've gone through and replaced all the electrolytics, probably better than maybe 60% of the resistors as well. And this is where we're at now. We got a functioning audio amplifier, but we still have no signal. This is the long wave band. This is medium wave. Let's try medium wave. We're getting nothing out of the AM tuner at all. Absolutely nothing. Long wave, I think. Yeah, there's nothing on long wave either. But there's no noise or nothing. It's silent. And FM. Turning this to maximum volume, and then we'll scan the band here. It seems to be getting very faint reception. Very faint signal. It's still not usable at this. It's too quiet. Something's not right here. And I don't think we're getting all the stations either. I got an aerial hooked up to what I assume is the input.
That your diamond was cut for maximum brilliance.
Spence Diamonds only uses diamonds of exceptional cut, so they shine nice.
You got a good audio quality, but it's just not no punch behind it, no volume. Yeah, there's a lot of dead air on this. I think we're missing stations. Something's not quite right. Plus we got no AM whatsoever. Try AM band again. And there's nothing. Not even a twitch. Now I did go through and I checked all these switches because they were, when I first powered the radio up, they seemed to be causing a lot of problems. But I did shoot some cleaner in the backside of these switches, and I went through with a continuity checker and I checked all the contacts, and they're all working. All the switches are making contact, so I'm not worried about the switches at this point too much. So it doesn't really...
Non-stop hit all day.
Every day.
1049.
Virgin Radio.
Switches are fairly clean. So, what do? Well, I think we got problems in these modules. There's two modules. If I look at the instructions, they don't give you any information. They just show them as black boxes. What's going on here? They show the modules. They don't even show circuit diagrams for the modules. Just a box here, a box here, and they tell you if they need servicing to send them into the manufacturer, which I don't have the option to do. So I might have to open these up and see what's going on with these two modules. The first module here, let me disconnect the power. First module here is buried under this switchboard, so I'd have to remove the switches to get at the solder connections for this module, the IF strip, which I think is bad, which is the reason why we're not getting any AM reception. So let me do that. This is the FM module here, the VHF. It seems to be working, but it's very quiet. So let me go after this module first to see if this helps the situation. There's really no indication of where the signal flows from one module to the other. Like I have my volume control here, and if I sat down and figured out the switch positions, I could determine VHF. Yeah, I'm going to have to examine this because depending on how the switches are set up, it depends on how the signal flows through here. But I have a feeling the signal for the FM tuner flows through this IF amplifier. I'm not 100% sure on how this works because it's all blacked out on me. But let's pull this IF amplifier out first and have a good look at it. Maybe we got failed components in there. I have a feeling we do, which means I have to disassemble these switches. I have to remove all these jumper wires. There's quite a few of them, and it's all quite a mess in here. So I'll have to work on getting this out. I'll take some good pictures of this and get these switch assembly out before I can attack the module. Okay, so we're going in. We're going to ignore the warning and we're going to open this up. This is the IF module, and it looks like somebody peeled this sticker off before and maybe re-glued it, because it wasn't exactly like that. Interesting. Anyways, so here it is. Let's open this thing up. Maybe I got You focused in a little too close. Let's go like that. All right, look at this microelectronics from 1960. Some pretty tiny printed circuit stuff going on here. Wow. So how do I get into this thing? I think I have to. Well, there's a ground tab here and one here. I need to lift those. So let's lift those tabs. Actually, what I'm going to do is get rid of the solder. And then we can see what we're up against here. I think this one here, I have to bend these out. Okay, I think I can see where I'm going now. So I want to lift these tabs up without tearing the foil on the PCB board. That's why you heat it first. All right. Okay, we should be free. Yes. So what do we got here? We got 3 transistors. 3 transistors. Looks like 1, 2, 3. AF115, AF116, AF115. These all look like electrolytics. 1, 2, 3, 4, 5 electrolytics. 1, 2, 3, 4 diodes. Is that right? Alright, so let's get a look at the electrolytics. We got a really weak signal going through this, if any signal at all. I want to clean this. It's hard to see anything with that. Okay, first let's do ESR on some of these caps. Because that's probably where we're going to see our first fault. It's hard for you to see that readout, isn't it, with the folder? I wonder if I stand it up somehow. Maybe that's better. Got it zeroed out. Yep. Okay, some 10 microfarad. We've got 4, which isn't great, but it shouldn't stop it from working. This one here. 4.2, that's another 10, I'm assuming. So 10 here. .6, and then I have a couple of these. What is that? 10. .3, and the last one is right here, 6.6. Okay, this is a 2.5 microfarad. This one's a 10 microfarad. 10, 10, 10. So those readings aren't too bad. for what it is. Beginning to think we might have a dead transistor in here somewhere. So we need to get the diode checker out and check some of these. All right. I don't know the pinouts on these things. Put this on this side, I think. That makes it easier. Okay. I think the base is in the middle, I'm not sure. 0.33. 0.33. So I have a feeling that's working. 0.33 is a bit high for germanium transistors. It should be around 0.25 or so. But we're just going to leave it at that for now. Let's check the other ones. Which is right. They only have 3 leads on these, right? There's no. Okay. See, that's more like a germanium 0.21. Huh. I wonder if that's open. 0.2. Oh, that looks good. We might have a bad junction here. 2.211. The other way around is 0.212. It's interesting. I might have an open or a bad junction here. Let's try this one. There is 4 pins on these. That's what I was wondering. I guess one is going to be a case. So I need to figure out which one the case is. There's the case, okay. So the other 3 are a transistor. Okay. That one checks okay. This one here. That's the case. There's the case. Okay, so it's really hard to tell on these germaniums. They're all over the place with their readings, but none of them are shorted. Everything looks good so far. I'm going to check some of these diodes too while I'm here. I got the tools out. Let's do it. What do we got here? Okay, that's one diode. And there's another one down in here, right here. That one's good. Another one here. I think it's right here. That That one's okay. Last one. It's right here. That one's okay. So what is the problem? Now I'm assuming it's got a stacked IF because it's got the one transistor, but it's got two sets of cans, IF transformers. So I guess that's what they're doing here. We're getting an FM signal through. It's just weak. We're getting 0 AM through. We don't know if the AM oscillator is working or anything. So I'm going to put this aside and maybe pull out the other module. That other one has the tuning capacitor in it, and I have a feeling that one's responsible for the AM and FM tuning. Alright, so I got the tuner module out. It wasn't without a little bit of a struggle. It was kind of difficult. There's 3 screws. Well, here, let me go through this quickly. First of all, you got to remove the dial string, and dial string wraps all the way around, and then it does, I think it's 4 or 5 wraps on this spindle here, and that has to be all removed. And then you have to lift up this plate. This is actually an aluminum plate that covers over 2 mounting screws. There's 3 screws total, and these 2 are covered, so you have to kind of carefully bend this up. You don't want to crinkle it or crease it, because you're going to be gluing that back down when you're done, and you want it to look, you know, undamaged. So it's not the easiest thing to get out. And then excuse me, and then all the wiring has to be disconnected. So what we're staring at here is the module itself. It's the tuning shaft, and there's a gear reduction here. Tuning capacitor, you can see it there. There's 2 screws underneath holding it to the cover, the bottom cover. This cover is going to be a little difficult to get off because it's soldered on all 4 sides. It's soldered, and I'm going to have to fight with this to get this cover off. But once I get this cover off, it'll expose all the top side of the printed circuit board. And to get the bottom side off, if I need to do any repairs, I'm going to have to remove all of this, and I'm going to have to remove this this press-on nut that holds on the tuning sector gear, and pull that off, and then I'll remove the 2 screws on the tuning capacitor, and then the bottom cover should remove. But let's try and get this off. I'm not going to run the camera doing this because it seems like it's going to be I'm going to need both hands putting a lot of heat to this, and my solder sucker will suck out most of the solder, and then I'll have to maybe lift up the tin. I don't want to damage the tin box at all, because it's part of its identity is this the way it's put together. So let me fight with this, get the covers off, and then we can have a peek inside. Okay, what a pain in the butt that was to get open. You have to remove all of the attachments on top to be able to get these 2 screws out, because you want to remove this cover, not the other cover. This cover is soldered to the PCB board, so it's not coming off first. It's soldered here, here. So now that I got the cover off, I can put this aside, and I can remove this printed circuit board. I can't imagine them wanting to repair these Rogers, wanting to get these for repair. I think they just probably toss them in the garbage and give them a new one. But we got a couple of grounds. We got one ground on this capacitor here. I'll just lift this one up. Get a little heat on it first. Okay. And then we're going to need to heat up these 2 and remove some solder from printed circuit board here. Let's see if we can do this. I don't think I got it yet. Okay. The thing is, you want to go really slow and attack this with some precision, because you don't want to be damaging any of the traces on the printed circuit board. They're pretty fragile. So let's see if we got that enough. Nope. Still wants to hang on. Okay, it's going to have to do. Now, we should be able to peel this out. That's loose. That's loose. Anyplace else? I think that should come right out now. A little bend on that, maybe. There we go. All right, and we're in. 2 transistors, BFs 195s. Little tuner assembly. Okay. I should actually remove this purple wire too. It's just going to break off eventually. Okay, where's our diode checker? Let's check these 2 transistors. I have a feeling I got a dead transistor in here, but could be wrong. So now I think let's see here, from this emitter base collector. So this should be emitter base. Something's wrong with that transistor. It doesn't. Got a diode junction there. The other side I have, it's like it's open. Okay, the other one. They're both testing the same. I don't think they would change the pinout on. There we go. Maybe it's base collector emitter. That one right there and right there. The other way. Alright, so on the tuner module, what I've done is I removed these 2 transistors, tested them out of circuit. They're both good. They have a gain of about 50 each, which I don't know if it's right or not. I have to look at the spec sheet for a BF 195. But they're both behaving normally. I also checked the resistance of all these resistors. They're within tolerance. And that's pretty much it. What else I did? I resoldered the board because a lot of these joints didn't look too strong, and I just gave them a little bit more solder so that they could hold on better. And I gave it a good flux clean. So this is all ready to be reassembled and put back. As far as I can tell, I can't find anything wrong with this board. Now, I was on the internet looking for schematics for these modules. These are Mullard modules, by the way. Here's the case for this one, and it's an LP1171 module, and I guess it's a fairly common module that's used in Roberts radios. It's a Mullard, made by Mullard, and doing some online reading, and I stumbled across one YouTube channel, Radio Cruncher. He's got a very good channel. have to go back and watch some more of his videos. But he services these modules, and I guess the major complaint with these radios and these modules is these germanium transistors develop whiskers, and then they short out internally, and then the radio stops working, which kind of sounds suspicious in my situation here, because I think I have something like that along the lines too. So let's check. You just go through with an ohm meter and check between the shield. These transistors have 4 pins, emitter, base collector, and then they have a 4th pin as a shield. And if you look down underneath the pins, where the pins are, you can see there is four wires coming out of that transistor. So what they're doing is they're grounding the shield to a outside ground point to reduce emissions, I guess. I don't know. Now let's check this with a continuity checker. So if we check from transistor to transistor shield, we're getting dead shorts. Okay, which is fine because we know they're in circuit. And now if we check how the grounds are, where they connect, I suspect it connects here. This is a ground here on this pin because this connects to the case of the shield. So let's try this here. Connect to this pin, and again we get 0 ohms, which means they're all connected together. I think they're connected with these cans as well. Yes. So what do? Well, let's check for resistance between the shield and the pins. So here we go. We got 4 connections here. Let's try this one. It's about 11K. 11K. 12K. That's our shield. This is a collector. We got 240 ohms on the collector. That's not good. Okay, let's check the other one. Which one is the shield? That one, no? Okay, here's a shield. Here's a collector. And we got 15 ohms. I think this one here is emitter, and that's 34K, and base I think is about 11K. Last transistor, it's right here. That's the shield. No, that's not the shield. This is the shield. So this is the collector. 120 ohms. About 10K. 10K. So let's pull those 3 transistors out. Might have to take a photo here on how these transistors are orientated, and we'll test them out of circuit. Okay, let's pull these out and check them out. I changed meters because I have the clips on these ones, and it makes it a little easier to clip them on the leads. So let's clip to the shield. Just want to test we have the shield. Okay, so let's try the collector first. It's open. It's open. That one looks good. This transistor looks good. There's nothing going on between the shield and any of the connections. Okay, let's pull up this other one. You got 4 pins here. They got 3 spaced close together and then 1 off by itself. And the shield is the one in the middle. That is there, and then the collector is the one off by itself. So this is a collector. Let's see what this says. Getting hundreds of mega ohms here. So that's debatable. Same on that one. And last pin, expect it to be the same. Yeah, so we got leakage there. It's in the about 100 mega ohms range, which isn't critical for a application like this, but it's eventually going to get worse, right? So we're going to need to replace this transistor. Let's do it the other way around. Reverse junction, 27 mega ohms, 30, 27. So that's probably not the cause of our problem, but it is a bad transistor. Let's try the last one. This is a 116. I have this feeling this is the one that's bad and causing me headaches. Okay, where's my other clip? I think this is the one that measured 15 ohms, the collector. So let's try this. Yeah, there we go. 15.5 ohms. That's a problem with the radio. Open. Is that 300K? Yeah. Doesn't want to read backwards. Here we go. 20 ohms. This my leads are clip leads are flaky. Okay. Open. 6 meg. Okay, this transistor is definitely bad. Now, this is the first time I worked on a Roberts radio in any of these modules, so this is all new to me. That's why I was kind of thrown by this. The transistor tests fine. If I put in a transistor tester, let's try it right now. These are PNP transistors. So let's try, where's collector? This one's base. I think base is this one in the middle. And then the last one is the emitter. So it's PNP, switch it over, and you can see by the light, it is working. That's odd. It's got an odd characteristic for a transistor. I've never seen it happen like that before. Emitter. I'm going to switch these two around. Emitter collector, emitter base. I just want to make sure I got them hooked up right. Because this won't work if it's not hooked up right. Yeah, it's not working. So that was the right way. And the transistor does work. It's just got a shield to collector short, 16 ohms. That's what's killing the radio. Okay, I essentially have three to pick from here. I got a GT109L, which equates to a 2SA49. And I believe a 2SA49 is like a low-level RF-IF transistor. And I've used these in the Harman Kardon 230, and I had success with these. These are good little small signal transistors. This one here is a GT313, and it equates to a 2N502. It is a I'm not really quite sure what this transistor is, but it does have the shield on it for the case, which is not necessarily, but it's a nice addition. And here's a GT309A, and this one equates to an OC57. I think this might be an audio transistor. I have to check on these, and I'll pick the one that is best suited for the application, and I think I'll install them because it's what it needs. Now, these capacitors, I did check them and they were okay. I wonder if I should pull them out and maybe ESR them properly. They're probably pretty tired, and they would benefit if I did a recap on this, and then I wouldn't have to ever come in here again. These caps are, well, they're from the 60s, so they're pushing 50 years old, these caps. I just want to give a little shout out to Oleg. I bought a bunch of transistors off Oleg on eBay. He goes under the eBay store of Softcom, and you can read this here. They specialize in selling new old stock of Soviet components, and they have a lot of different stock. They have not just transistors, but they have capacitors, they have, you name it, they have it. Special diodes, special semiconductors, special capacitors, you know, all for the military industry. And I asked Oleg if I could give him a shout out on my channel, and he said sure, go ahead. He goes under the profile of Alex ER1, and if you go on eBay and you search for, I don't know, either Softcom, I think, or Alex ER1, you'll see the Russian germanium transistors pop up, and I bought lots of them off them because they're cheap. They're super cheap. Like these ones, for example. These are what are these? GT403s, and these are suitable. These are suitable for audio output transistors, up to about 4 watts dissipation. These are PNPs, germaniums, and you get lots of different types of transistors. I'm just going to go through the spiel here. This one's a 320A, and these ones have no shield. But these, I'm not sure exactly what these are for, but I think a lot of them are for audio stages. And here we got a few other ones. These are audio transistors, low power, MP37s. GT109Ls, little tiny ones. So I get lots of these transistors from Oleg, and they're dirt cheap too, so there's no excuse for not having them. You go to NTE and get a ECG germanium transistor, you're going to probably pay 20 times or 100 times what you can get these little transistors off from Oleg on eBay. So there's no excuse for not having them. They're cheap. You just got to do your homework on specifications and, you know, frequency and voltages and all that. You have to look at the data sheets to see what they're suitable for, because a lot of these old germanium transistors had limited application, right? Because they had either they operated at low voltages or low currents or low power. So you have to be careful when you're using them. But in a situation like this where you got IF strip, it's perfect, you know. So yeah, shouts out to Oleg on eBay, and great seller there. I highly recommend him, that you go if you get some germanium transistors. If this is your thing and you're constantly looking for germanium transistors, go to him and buy them. Shipping's pretty good too. He gets them to me probably within 3 weeks from the Ukraine to Canada, so I can't complain about that. That's pretty good. And I've bought a few batches of transistors off him, and like I said, no complaints. Oleg's a stand-up guy, and he's good to deal with. So, well, hello. So it is now 19 months later. Everything you saw previous to this clip right here is 19 months old. So let me explain what's going on here. What I did is I experimented with a few different transistors in this module. What I did is I put in the GT309As and installed the module back in the radio, tested it out, nothing, didn't work. So then I went back, pulled it out, and I installed it with these, what these are, let me see. These are GT322As, and these ones have a metal can shield on them. Put 3 of these in, same thing, nothing, didn't work. So I'm like, what is going on with this? So I got frustrated with it, and I put it aside, and here we are 19 months later, and I've been itching to get back to this because I don't like things hanging like that. It was all ripped apart, and it was sitting in a tub, and it was waiting for me to revisit this. So I got annoyed the other day tripping over it, and I said, let's work on this again. So I pulled the module, I pulled the 3 transistors out, the 322s, and I pulled out my curve tracer for my transistors, and I started plugging some of these transistors into the curve tracer, and I found something really interesting. These GT322As, they don't even look like a transistor on the curve tracer. It looks like it just looked like a mess. And then when I put these ones in, these 309s, they had a nice curve, and everything was going good. Plus, also I checked the gain on the original AF 116 and 115 transistors that I pulled out of here, and it was around 117 or so for gain. And these ones here have a gain of about 62. I know it's not matching up, but it's close enough, because a lot of these ones I tested, they have really low gain. So what I did is I put these GT309s back in and reinstalled it. That is a job in itself, just putting this module, taking it out, putting it in, because they got all these connections that have to be dealt with. And this switch bank has to be lifted, and there's a solder connection under there, so yeah. So anyways, I put the 309s in, and I'm itching to test it here because I haven't powered this up yet. So let's do that right now. Let's power it up and see if it's going to work. Let's put our 9 volts, and let's hook up a bench speaker. All right, here we go. You can hear hissing out of the speaker. Oh, there we go. What's this?
Set in Hawkins in 1959 that features young version.
It is working. It's got good volume. Okay, so that must be medium wave. This would be long wave or short wave, I'm not sure. But that sounds like it is working. It's definitely tuning stuff. Okay, let's try FM. Uh-oh. FM is silent. Is it silent or is it working? Let me see, we got an antenna here. Hey, it is working. It's very quiet.
Décédé à Los Angeles à l'âge de 89 ans.
The amplifier sounds good. So it looks like we got a working radio now. Right on. Okay, well, I can finish this video and put it together and post it, so it's good news. So let's get this finished up. Now, do I dare try an alignment on this thing? Because you know what, I'm going to try it. I'm going to try going through some of these steps to see if we can make this a little... The AM seems...
certainement vous dit quelque chose. En tout cas, si vous évoluez dans les eaux du jazz.
It doesn't sound too bad. It's a little weak on the FM.
Avec son frère.
Okay, good. Let me try adjusting some things here and see if we can get a little better reception out of this. That really surprises me because I did try these transistors out before and they didn't work at all. So maybe I screwed something up. But it's frustrating because this module is so difficult to take out. And once you take it out, you really have no way to power it up and test it because of the convoluted way it goes into the circuit. Okay, let's finish this one up. Alright, so I had a little read through the calibration here, circuit alignment section. It seems simple enough. My biggest problem here right now is this Roberts radio on their Ultimate Wisdom. For whatever reason, they put meters here on their scale and not kilohertz like everybody else on the planet. They did the megahertz for FM. I don't know why they didn't carry it through in long wave and medium wave. They put meters here, so this is really frustrating. But the instructions give you enough here to go by. So first step is I have to feed in a 1500 kilohertz, and I'm using my loop antenna here I just made up. But I have to adjust this, slide this back and forth, and it's all cut in with wax and holding it in place. So it's going to take a few minutes here, and I'm just going to clean the wax off the antenna bar, and then we'll get back to you here. Okay. Alright, so I got the wax off this bar, and we can slide our coil now. And what I'll do is I'll fix it with hot glue after I'm done, just to tack it so it doesn't move. So first step is switch to medium wave, which I do, and tune the radio to the 200 meter calibration mark. 200 meter calibration mark is right here. I'm exactly on it, centered. And let's see here. Turn this on. You can hear my signal generator. It's very close. Adjust AM oscillator and aerial trimmers for maximum output. And those are I believe this one and this one. Very touchy. Okay, I have a meter hooked up to the speaker so I can see visually the output, and I think right about here is good. Even though you can't tell the difference using your ears, you can see the difference on the meter. Right here. Okay, and this should be center. Of the frequency right here. Right there. That brings it in. Okay, so we're right on 200. So next step, tune the receiver to the 536 meter calibration mark, which is on the other. Right there. There's a little dot here on the scale. Right there. And 560 kilocycles. 560 kilocycles. Okay, so let me reset my signal generator. Okay, so let's turn this up. How far off are we? So I have to slide this back and forth to tune it. It's not a very good method of tuning. It's right there somewhere. Having a hard time with this one. Okay. Oh, we're way off. Right there, it sounds like, but it's so poor. No, that's not right. Oh, okay, so it's just the AM oscillator coil core. Okay, so that is located right here. And that's that red one. Okay. Let's try this. There we go. Okay, let's peek this one. I think it's right here is about best. This little rubber thing fell out. Yeah, it's good. So medium wave's done. Now let's do the long wave. 263 kilocycles. I don't know if my generator will go that low. Okay, long wave. Set the pointer to the 200 meter mark. And I set my generator to, what is it here? 263 kilocycles. And adjust CV1 and CV2 for maximum output. CV1 are these, this trimmer capacitor, this trimmer, these two, the brass colored. So let's try this. Okay. So this one's oscillator coil, or oscillator trimmer, and this one's your antenna trimmer. And they're both good now. Okay. Perfect. Tune the receiver to the 536 meter mark, which is way over here. This little dot just above Vienna. A little dot there. And feed in 158 kilocycles and adjust L3. L3 is this one on this end. I don't know. It's loose. Let's turn it 150. What is it again? 158. Here it is. We are right on. No need to adjust. Good. Everything's good. Let's do the FM now. Okay, we're on FM now, VHF, and I have my signal generator tuned to 108 megahertz, and I have this tuned to 108 megahertz, and there's no signal generator on the scale, so we got to adjust this. And I believe the oscillator and which is the FM oscillator. FM oscillator will be this one.
Safe and fun.
I'm not hearing it at all. Let me try 107 megahertz first. Switch this around. See if we can hear that. There it is. Okay, so we got to go at 108 megahertz. Okay, so increase this. No, it's not there. I know we have a station right at 107.9, maybe that's the reason why. So let's do this different. Let's set this to 106. Okay. And I'll set my generator to 106. And then we'll do it that way. And it just went pop. And it died. What's going on here? And we got it back again. You can hear it just buried by that station. If I turn it up, yeah, see it. It's going overloaded again. I think these switches are that's the problem I have with tuning FM receivers at my place here. We got some high power stations right at the very top of the band. Yeah, it just doesn't like that at all. Turn down that volume on that signal. It seems like when the signal gets too strong, it just swamps it. Let's turn this. Right there's the peak. And that's at 106 megahertz. 106, okay. Now we trim this. We turn down the signal. And I completely lost it again. Turn it back up. Oh, this is rubbish. The FM on this is not playing nice. Something's killing the oscillator. Something right there, I think. That is a RF. Is that an RF gain adjustment? I'm not sure. Seems as if I give it too much, it stalls the oscillator. If I turn it too much clockwise, you know, it just falls flat in its face. Weird. Well, I'm going to adjust it for maximum, which is right here, and leave it. That's all I can do. And I'm just going to lock this coil in place. Don't go crazy with this stuff. Let's put a little bit on. There, should be good. And we are done. Okay, let's assemble this thing, get it out of my hair. I'm so sick of looking at this. I just want to be done with it. But we can. Let's see here. I think this goes from the top or from the bottom. Let's try from here, because it doesn't really matter. Oops, that's not what I wanted to happen. Let's try it this way. Okay, clip this on here. All right, here's our antenna, our wires, everything's good. Let's put it back in the case. This goes like this. Ah, missing one thing here. I need to put this on. And this goes like this, I believe. There. And we can put this in the case. Woohoo! All right, now the screw here for the antenna. Okay, one screw for this. There's a lock washer on there too, isn't it? Yeah, there's a couple lock washers. Okay, so let's put a lock washer on. Get this side. Crazy. Let's get this side, another screw, another lock washer. Boy, I'll be happy to see the back end of this thing. It was one frustrating trip, this one. And I don't even think it's working properly still, because I think it has a problem on the FM band. It goes in and out of, heat up my iron. I'm not going to do anything with this. This is just going to be a display piece. If anybody ever wants to listen to it, they're going to have to hook up 9 volts. Let's see if I can wire these together. Wrap these up. I don't know, you guys in Britain, you see a lot of these radios. I don't know how they perform. Are they pretty good performers? Because this one doesn't seem to be that great. And we'll see how this one goes together. All right. That's as far as I'm taking this. Put this back together. There we go. And there it is, all done. Here's a look at the parts that went into this thing, or the parts that came out of it. These are all the electrolytics. Now, some of these are still good, but I just replaced them as a blanket. Yeah, they're still good. These resistors are out of tolerance, so they got yanked out. And these 3 transistors, I think 2 of these are okay. And one of them had an internal short, but I cleared it when I did the capacitor, charge up a capacitor and put it across. And it seemed to clear it up. So I'm going to put these back in my inventory, and who knows, maybe in the future if I need one of these rare beasts. I know we don't see these very often in North America. They're just not available. Yeah, yeah, I'm gonna hang on to these. Maybe I can use them somewhere. Who knows? But that's it in a nutshell. Well, that's the end of a journey for sure. All right. Thanks for following along, and thanks for your patience. I'm gonna put this on display. I'm not going to fiddle with it anymore. It needs a little bit more cleaning. Yeah, I'll do that. But thanks for watching, and hope to see you on the next one. After this, I hope. Take care. We'll see you.